introduction of minimum spanning tree.
A spanning tree is defined as a tree-like subgraph of connected undirected graph that includes all the vertices of the graph. Or to say the layman's words, it is a subset of the edges of the graph that from the tree, a cycle where the every node of the graph is a part of the tree. The minimum spanning tree has all the properties of spanning tree, which added having the minimum possible weights among all the possible spanning tree. Like spanning tree, there is can also may possible MST of a graph. Properties of the spanning tree. The spanning tree hold the below methods principle, the number of vertices in graph, and the spanning tree in the same. There is fixed number of edges spanning tree which equal to 1 less than total number of vertices. The spanning tree should disconnected. There should be only single source of the component, not more than one. The spanning tree should be acyclic, which means that would not be cyclic in the tree. The total cost of the spanning tree is defined as the sum of the edges, weight of the edges, and spanning tree. There can be many possible spanning tree in a graph. Thank you.
In minimum spanning tree, there are two types: Prim's and Kruskal. I am going to say about Prim's minimum spanning tree. We have discussed about Kruskal algorithm of minimum spanning tree. Like Kruskal, Prim's also is a 3D theorem. This algorithm always starts with a single node and moves through several adjacent nodes in order to explore all the connected edges along the way. The group of edges that connected two sets of vertices in a graph is called cutting graph theory. Also, the step by step, at every step of Prim's algorithm, find a cut, pick up a minimum weight edges from the cut and include the vertices MST set and the set that contains already included vertices. How does the Prim's algorithm works? Step 1. Determine the attribute vectors as the starting vectors of the MST. Step 2. Follow the step 3 to step 5 until there is a vertices that are not included in the MST. Step 3. Find edges connected any 3 vertices, the fringe vectors. Step 4. Find the minimum along these edges. Step 5. Add the choice edges to the MST if it does not form any cycle. Step 6. Return to the MST and exit. Next, Mritul will explain the Kruskal algorithm.
Here we will discuss Kruskal's algorithm to find the minimum spanning tree of a given weighted graph. In Kruskal's algorithm, sort all edges of the given graph in increasing order. Then it keeps on adding new edges and nodes in the minimum spanning tree. If the newly added edges does not form a cycle, it picks the minimum weighted edge at first and the maximum weighted edge at last. Thus, we can say that it makes a locally optimal choice in each step in order to find the optimal solution. How to find minimum spanning tree using Kruskal's algorithm? Sort all edges in non-descending order of the way. Pick the smallest edge. Check if it forms a cycle which spanning tree formed so far. If the cycle is not formed, include these edges, else discard it. Repeat step 2 until the given edges is in the spanning tree.
Next, Gautam will explain about the applications of minimum spanning tree.
The application of minimum spanning tree. A minimum spanning tree is the subset of the edges of a connected undirected graph that connects all the vertices together without any cycle and with the minimum possible total edges weight. It is a way to find all the vertices in a graph in a way that minimizes the total weight of the edges in the tree. MST fundamental problem with the application. Network design. Telephone, electronics, TV cables and computers, etc. The standard application is the problem like phone network design. You have a business with several offices. You want to lease the phone lines in to connect them up with each other, and the phone company charges a different amount of money to connect a different pair of cities. You want a set of lines that connect all the offices with a minimum total cost. It should be a spanning tree. Since the network isn't a tree, can always remove some edges and save money.
Thank you.